Lesson 4.4b. Solve inequalities by addition and subtraction. Solving an inequality means finding the values for the variable that makes the inequality true. You can use addition and subtraction properties of inequality to help solve it. When you add or subtract the same number from each side, the inequality remains true. These are exactly like solving equations, except you have an inequality symbol in there, not an equal sign. So less than or greater than, less than or equal to, greater than or equal to. But these are going to be one step today. You're going to undo what you see to get the variable alone. One rule that I'm going to make for this today will be that the variable must be on the left. If the variable's not on the left, you're going to move it over there, and I'll show you how to do that. So if we look at the very first example, x plus 4 is greater than 9. You need to get rid of plus 4. So you do the opposite. You subtract 4 from each side. So we've got minus 4 here and here. These two go away, so x is greater than 5. That means that any number greater than 5 would make that statement true. So if I put 6 in here, 6 plus 4, it's 10, isn't it? So 10 is greater than 9. 7's x is greater than 5. 7 plus 4, it's 11. Isn't 11 greater than 9? Yeah. So you're finding a whole set of numbers that make this true. Let's look at the second example that they have here. Negative 12 is greater than or equal to n minus 9. And I've got to get n alone. Andrew.
When we do these, we only write one of the numbers, or do we write all?
No, you don't. You write, listen, if you write x greater than 5, you are really writing an entire set of numbers, like an infinite amount, by just saying x greater than 5, because that's every number greater than 5, okay? But you only write x greater than 5.
I don't get it.
You're writing a whole set of numbers. Anything greater than 5 would make that true. Anything greater than 5 would make that statement true. All you have to write is x greater than 5. And it means anything greater than 5. Okay? Now, negative 12 greater than or equal to n minus 9. So I want n alone. I want n alone. So I'm going to do the opposite of what's right there by adding 9 here and adding 9 here. So these two disappear. And on the left, I'm in the whole 12 and I gain 9. So that's negative 3. Now, you see how my variable is on the wrong side? So this one you don't want to do. You turn it around by just flip-flopping the n and the negative 3, and then this one, you see how it's pointing to the n right there? Make sure you flip it around so it's still pointing to n. So instead of greater than or equal to, it's now less than or equal to. Dylan.
What is the line under the inequality?
So you guys don't know about inequalities at all, do you?
Nope.
Okay, well that explains a lot. Caden.
So two things. We kind of did this last year, but we didn't know the name, and
Okay.
so you just flip-flop.
Yes, let me start over. I thought you guys knew inequality, so let's start over. Here we go. Are you ready? There is less than. A less than kind of looks like an L. If you raise your left hand and stick out your thumb, you've got an L, right?
Yeah.
But when you squeeze it together a little bit, it becomes a less than. A less than, I consider that's the point right there. You see that?
Yeah.
You see how it's pointing to the left? So less than is pointing to the left. Greater than is pointing to the right. Pointing to the right is greater than. The first thing is greater than the second. Now, if you put a line underneath, that is considered less than or equal to. Let me give you an example about that. Less than or equal to. So, let's say you save up money all year to go Christmas shopping, and you save up $100. And you go shopping on Black Friday and you want to get it all done. You go through your whole list and you spend exactly $100. That's okay, isn't it? Yeah. You've saved up $100, so it could be equal to $100. But you would be just as happy if you got done and you had money left and you spent less than $100, because then you could take the money and go buy a present for your favorite math teacher. Right?
Yeah.
So less than or equal to $100 is okay. It's like it's an upper limit. It's an upper limit. So greater than or equal to, greater than or equal to. So you go and you have to, I don't know, I'm trying to think of an example. Okay. All right, so let's say that you wanted to buy a, let's say you wanted to buy a cell phone yourself. And you got a job to buy the cell phone. Okay? And the cell phone that you wanted cost $300. And you had to work really hard to earn that money, right? And you worked and you worked and you worked and you earned exactly $300 so you could get that cell phone, right? But wouldn't you be happy if you could earn more than $300, because then you'd be able to pay for the actual data and stuff for the cell phone, right? So greater than, well, we're just saying, for example, it's $300. Okay, so maybe you need the extra for the tax. But you would be happy with greater than or equal to. You would need to earn at least $300, right? That is what at least means, greater than or equal to. So this one is also at least. Think of it that way. The less than or equal to, think of it as at most. Okay, so for right now, we are really just going to be concerned with the solving of them. I'm going to show you about graphing too with these to let you understand what those things mean. Let me scroll down here just a little bit. Does everybody have that written with the less than and the less than or equal to, greater than and all that? Okay. I thought you guys had already done that. So let's scroll down a little bit.
Yeah, what we did last year was we had two numbers and we said one greater. Or like fractions.
So you were just checking numbers out. Okay, well, these are solving. All right, so now we're going to talk about this as far as graphing goes. So we need to do the graphing rules too, and I'll write those down. Make sure you get these. This example 3, a plus 1/3 is less than 1. Well, just like any other solving, if it's plus 1/3, you're going to subtract 1/3 from each side. That makes this go away completely, and a is less than 2/3. Now, when we say a is less than 2/3, that means any number less than 2/3 works. And it is shown by graphing it like this. So let's go through these rules. Are you ready? Write these down. If it is less than or equal to, you're going to shade left. Less than or equal to. Now think about a number line. Where are the smaller numbers? Left or right? The left. So if it says less than or equal to, you shade left. That's where the smaller numbers are, the less. If it's greater than or equal to, where you think you're going to shade?
Right.
Shade right, because that's where the greater numbers are. Now, you see how that circle, it looks like it's a little open dot there? Okay, there's a way that you can tell whether that should be open or closed. If it's less than or greater than, it means that number is really not part of it. It's just a boundary, less than or greater than. So in that case, it's an open circle. if it's less than or equal to, greater than or equal to. So that's like my example of I could spend exactly 100, but I'd be happy if it was less. If it could be exactly that number, then you close the circle. So when it's or equal to, it's got that extra little line, then you put that extra little amount in the circle. You fill it in. So what I want to do right now is definitely look at all 6 of these examples. Let's start with number 1. It says that t minus 6 is greater than 3. If I want t alone, this is just like our one-step equation. If it's t minus 6, what should we do to get t alone? Mason.
Add t. Wait, no.
We want to get t, we got to add 6. So add 6 there and there. This falls out. This is just like one-step equation. So t is greater than what? What's it say? 3 plus 6. 9. Okay, example 2. B plus 9 is less than or equal to 2. We want B alone. Dylan.
Subtract 9.
Subtract 9. So B is less than or equal to what? 2 minus 9.
Negative 7.
Negative 7. Good. Okay, number 3. 8 is less than r minus 9. I don't want r minus 9. I want just r. So what am I going to do to get r alone, Liam?
You're going to subtract 9 from 8.
No, it's minus 9 already.
Add 9.
Very good. I'm going to add 9. Okay, now when I do this, what is 8 plus 9, Liam?
It's 17.
17 is less than r. What did I tell you about the variable?
You want to flip it.
You want to flip it. So what you're going to do for your final answer is you're going to bring r to the left, 17 to the right, and you're going to turn around your inequality. R greater than 17. This would be the final answer. Okay, number 4. Negative 4 is less than p plus 4. How do I get p alone, Caden?
You subtract 4.
Exactly. Subtract 4. So get rid of those 4s. Now I'm in the whole 4 and I'm losing 4 more.
That would be negative 8.
So it says negative 8 is less than p. But Caden, we don't want p on the right, so what am I going to do?
So I just flip it.
So p is greater than negative 8 would be my final answer. Okay, they're going to have you graph some of these. So s plus 8 is less than 9. If you want to get s alone, I'm going to write it right here in the middle. To get s alone, I'm going to subtract 8. So s is less than 1. Okay, when s is less than 1, 1 is not a possible answer. It's less than 1. So you do an open circle, and which way is it pointing? And then you shade left because it's pointing left. It's less than. It's all the numbers smaller or lesser. Number 6. Negative 3 is less than or equal to d minus 2. How do I get d alone? I'm going to add 2. So negative 1 is less than or equal to d, but I want my variable on the left. So you turn the whole thing around. D greater than or equal to negative 1. If it's greater than or equal to, it could be a possibility. It is included. So you fill it in. It's just a big dot. And you shade right. Okay, let's just do somewhere we're just shading, just to see. All right, so with this inequality right here, let's say that I write x greater than 0. If I say x is greater than 0, is it an open or closed circle? If it's greater than 0, is 0 included? Right. No. So it's open. And then if it's greater than, which way do I shade? Liam?
You shade left. Or right.
Greater than is to the right. Greater than is to the right. Okay, let's do x less than or equal to 2. X less than or equal to 2. Open or closed circle. If it's or equal to, 2 is included. So closed circle, and it's less than or equal to, which numbers are less than or equal to? Left or right? Shade left. Shade left.